hydrometer, an instrument used to measure specific gravity of the fluid. So suppose this is the tube-like shape is there, and this is the free surface here, and from this free surface to the depth of the tube, that is Z, and area of the cross-section area of the tube, that is A, and suppose this is in the water, so density of water, that is rho of water. Okay, and suppose there is a small weight which is kept in this location. So weight of the body which always act in the downward direction, and buoyancy force will be act upward direction at point B. Okay, now the same tube kept in another fluid, suppose consider the density of this fluid here is less than density of water. So what will happen, this length, so the here that is a height, that is Z from the free surface, so here the Z will increase because the density is less as compared to water. So that's why the Z plus delta Z, that is the height, and here that is the buoyancy force, that is AB1. Okay, and weight of the body, that is W. So A is the area of the hydrometer. Now what is the floating condition of the body? The floating condition, that is equal to W, that is equal to AB. So what is the buoyancy force? That is the rho of water for this case. So rho of water into G into A into Z. A into Z means cross section area into this height, that is the volume. So omega of W into A into Z. So this is equal to W. And for this case, W, that is equal to AB1. So that is equal to rho into, so rho 1 into G A into Z plus delta Z. So Z plus delta Z, it is the height, the new height, Z plus delta Z. So from here, W1 into A into Z plus delta Z. So this is equation number 1 and this is equation number 2. So in that case, so here the density 1 is less than density of water. So that's why the height is increases. So here this is height Z and here this is height Z plus delta Z, because this density is lower as compared to this density. So that's why the height is increases. Now let's focus on this here. This is equation number 1 and this is equation number 2. Now from equation number 1 and 2, what is happen? So omega of water into A into Z, that is equal to omega 1 into A into Z plus delta Z. So from here, omega of water minus omega 1, that is equal to A into Z plus delta Z by AZ. Okay, so omega 1 by omega W, that is equal to Z by Z plus delta Z. So from here, S specific gravity of the fluid, that is rho 1, that will be equal to Z by Z plus delta Z. So this formula is applicable only when the density of fluid is less than density of water. So for that case, specific gravity, that will be equal to Z by Z plus delta Z. Now specific gravity of the fluid, if density of fluid is greater than density of water, then the formula will be Z by Z minus delta Z. So this is the important formula. Just remember this formula. Now let's try to understand one important question that is very, very important. So what is this question? So a hydrometer weight, that is 0.03 Newton, and has a stem at the upper end which is cylindrical and 3 mm in diameter. It will float deeper in oil of specific gravity 0.75, then in alcohol of specific gravity 0.8. By how much amount? So what is given in this question? So weight of the fluid which is given, weight of the hydrometer, that is given 0.03 Newton, diameter of the hydrometer which is given 3 mm, that is equal to 0.003 meter. Specific gravity of oil, that is given, that is 0.75. So what is the density of the oil? You have to multiply it by 1000 to the specific gravity of the oil. You can find out the density of the oil. So this is 750 kg per meter cube. And density of A, which is given, alcohol specific gravity given, that is 0.8. So what is the alcohol density? That is 800 kg per meter cube. So you have to find out the height difference of oil minus alcohol. So H of oil minus H of alcohol, that is equal to what? So if you want to calculate the weight of the body, that is equal to weight of the body, so that is equal to rho of oil G into pi by 4 into D square into H of oil. So from here, so weight of the body which is given, hydrometer weight which is given, that is 0.03. So 0.03 in equal to 750 into G, consider this is 10, into pi by 4 into 0.003 square into H of oil. So from here you can get H of oil, that is equal to 0.556. So 0.566 meter. So that is equal to 566 mm. Now if you find out the if you find out the weight, that is equal to density of a alcohol into G into pi by 4 into D square 0.003 square into HA. So from here, what is given, that is 0.03, that is equal to 800 into 10 into pi by 4 into 0.003 square into HA. So from here, you can get the value of HA, that is height of the alcohol, that is equal to 0.530 meter. So from here, you can get that is equal to 530 millimeter. Now, what is the difference between HA oil minus HA alcohol? That is equal to 566 minus 530 mm. So that is will be equal to 36 mm. So this will be our answer. Now let's try to understand on another question, important question. So important for gate exam. Now let's try to understand this question. A wooden rectangular block of length of L is made to float in water with its axis vertical. The center of gravity of the floating body is 0.15 L above the center of buoyancy. So what is the specific gravity of wooden block? So you have to find out the specific gravity of the wooden block. So what is given in this question? So here, this is the wooden block here, and this is the G is the centroid of the body, and B is the center of buoyancy. Now from this centroid of the body, the weight is acting, and from this point, the buoyancy force will act. Now consider the length, that is A, and width, that is B, and consider the height, that is L. L is the height of the wooden rectangular block. Now what is given in this question? The center of gravity of the floating body is 0. So the center of gravity of the floating body is 0.15 L above the center of buoyancy. So this is given. So here to here, the distance is given 0.15. Okay, so this is given 0.15. So if this is 0.15, so here to here, what will be the distance? That is 0.5 L, and here to here, what is the distance? 0.5 L. Okay, and if this is 0.15, so what is this distance? This will be 0.35. Okay, so if this is 0.5, if this is 0.5, so what is this distance? This is 0.15. So here to here, this is 0.35, and here to here, this is 0.35. So here to here, this is 0.35 L, and here to here, this is 0.35 L. Now we know that W, that is equal to FB. So W, that is the weight of the body, that is density of wooden block, into G into volume of the body. What is the volume of the body? That is A into B into L. So that is equal to density of the body, the buoyancy force of the body, that is density of water, into G into AB into what is this length? So this length will be 0.7 L. So from here, omega of wooden block, that is equal to 0.7 omega of water. So from here, omega of wooden by omega of water, that is equal to 0.7. So from here, the specific gravity of wooden block, that is equal to 0.7. So this will be our answer. The distance from the center of buoyancy to the metacenter is given by I by Vd, where Vd is the volume of fluid displaced. So what does I represent? So what is the meaning of I? I means that is the moment of inertia of a horizontal section of the body taken at the surface of the fluid. So this will be our answer. There is a 4 MCQ question out there. Option A is the correct answer. So what is the correct answer? That is moment of inertia of a horizontal section of the body taken at the surface of the fluid. Now let's try to understand one important question which is important for gate exam. So what is the question? So a solid cylinder of length L, diameter D, and specific gravity 0.6 floats in neutral equilibrium condition in water with its axis vertical. What is the ratio of L to D? So this is given in this question. So consider this is the solid cylinder here, and the diameter of the solid cylinder, that is D, and length of the solid cylinder, that is L. Now after this section, after this the fluid are there, and this is the free surface here, and this is the center of gravity, and this is the center of buoyancy. So consider here to here, the distance is h. So from here to here, the distance will be 0.5 into h. Okay, so in question, what is given? This is the neutral equilibrium condition, and you have to find out the value of L to D. So neutral equilibrium means Gm, that is equal to 0. Gm is the center. What is Gm? Gm is the metacentric height. So gm that is equal to 0. So gm we know that bm minus bg that is equal to 0, which is given in this question. Now for floating condition we know that weight of the body that is the buoyancy force. So what will be the weight of the body? That is the omega into pi by 4 d square into L. D square is the diameter of the cylinder and L in the length of the cylinder. That is equal to omega of water. So this is in water. So omega of water into omega is this specific weight. Okay, omega of water into pi by 4 d square. This area into h. So here to here the distance is h. So from here you can get the value of h that is equal to 0.6 L. Okay, so this value h value. So here the value of h that is equal to 0.6 L. Now if you want to calculate bg, so bg that is equal to if you want to calculate bg, that means this bg will be here to here the distance is 0.5 L. So here to here this is the total the total height is L. So from here to here the distance will be 0.5 L minus what is the value of bg. So bg will be 0.5 h. Okay, so this is 0.5 L minus here to here the so bg if you want to calculate the value of bg, so here to here this distance is 0.5 L minus here to here distance is 0.5 h. So from here 0.5 L minus 0.5 into what is the value of h? H that is equal to 0.6 into L. So 0.6 into L, so that is equal to 0.5 L minus 0.3 L. So that is equal to 0.2 L. Okay, now if you want to calculate the bm, so how to calculate the bm? We know that the formula that is equal to I by vd. So I that is pi by 64 t to the power 4. D is the diameter of the cylinder. Now that is pi by 64 t to the power 4 by pi by 4 d square into L. What is the value of L? That is 0.6 into L. So this L, that is the 0.6 into L. Okay, so from here you can get the value of bm that is equal to d square by 9.6 into L. Okay, now if you want to calculate bm minus bg, that is equal to 0. So from here, so what is the value of bm? That is d square by 9.6 L minus bg. What is the value of bg? That is 0.2 L, that is equal to 0. So from here d square that is equal to 9.6 into 0.2 into L square. So from here L by d that is equal to under root of 1 by 9.6 into 0.2. So from here you can get the value of L by d that is equal to 5 by 4 root 3. So this will be our answer. So this is very important question for gate point of view. Now now consider this is one sheep is there and this is the free surface here, and here to here the distance is known as free board, and here to here the distance is known as draft or draught. Okay, B is the center of buoyancy and G is the center of gravity, and this is the keel of the ship. Okay, so this is my handwritten notes. You can download it from the description. Like, share and subscribe my YouTube channel. Thank you.